Good afternoon. Today's going to be an interesting one. All right, so let's pin this comment. So, we are going to be talking about using hand pieces now that we are in post. So let's see if we can get Daniel on here. Hey,
Hey,
can you hear me okay?
yeah, I got you. How do I sound?
You sound fine. How's
Okay,
it going?
it's going okay. I have three kids under five. So
That's a lot.
yeah, we've been buying games off Amazon, like board games. They last about 20 seconds, and then we dispose of them. So
Yeah. So why don't you go ahead and introduce yourself so people know who I'm talking to.
my name is Daniel Call. I am the national sales manager for BNR, uh, and I've been with BNR for 15 years. I started in 2005. Um, I sort of worked from the ground up. I worked on the inside in the office on customer service and did after sales. So I turned a wrench and I repaired handpieces, learned the business side of it, and then became a sales rep on the outside and did that for 10 years. That's where I met Kyle originally. And for the last 2 years, I've been the national sales manager.
Sweet. Yeah, so I want to tell everybody how this, like, why we're doing this specifically. So I called you to ask you what we can do once we open up our office to make sure that we're doing things that are clean. We're trying to limit aerosols, we're trying to limit droplets. And you started explaining a bunch of stuff to me, and I was like, whoa, 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 whoa. Wait a minute. I think other people need to hear this as well. So you told me a little bit, but where should we start? You sent me some photos.
Yeah, I think the slide that you have up, or we can start on that
Right
system.
here. Yeah.
I mean, I was thinking about it, and I would like to sort of um, plant a foundation that nothing that I'm presenting as solutions are new. It's sort of our products are designed in such a way, the Swiss character of um, precision and accuracy and innovation, sort of, uh, is responsible for these products that I'm going to describe to you and the solutions that they could provide. It sort of reminds me of, the three little pigs. It's like you build your house out of stone for when the wolf comes, right? And so
Right. Well, that's the
there's
Swiss way of thinking, right? Do it once, do it right, even if it's more expensive, even if it takes longer. There's one way to do it, and that's the right way.
exactly, yeah. I mean, I would describe it as like just a very high ethics. They want to understand the spirit of the regulation, right? They don't want to just make a device to satisfy the language. They
Right.
want to understand the real spirit of what is, especially because there's people on the other side of this thing, right? There's not just the patient, but you and
Yeah.
your office and your staff. It's
Yeah.
something they take very seriously. So
Okay. I love that about everything that comes from Switzerland.
yeah,
Watches and cheese and dentistry and medicine. It's all very precise and clean and organized and designed. So, where should we start? Talking about things that handpieces could have or could not have that could cause problems or could help in this situation.
yeah. I mean, I think a little bit of historical context, right? So the last time that something like this happened, uh, you know from my historical knowledge, was 1996, and that's the year when the first AIDS patient was traced back to a dental office.
Hmm.
So it's been, a little over 20 years since something like this has been this disruptive and you know, forced the magnifying glass over the
Yeah.
dental business. And really people started asking questions, right? That they weren't asking, or weren't paying attention to before.
Yeah.
If you look at, so my training, I'm engineering minded. You know, I try to apply that into clinical dentistry, and it's very difficult for me.
Yeah.
All the clinical side stuff that you're so good at. I look at the eyes through the world of an engineer, and if you look at a dental operatory, if you look at a delivery unit, and if an engineer who's never seen one of those was to try to design a bacterial trap, right? I mean, it wouldn't be very far off. So
Right.
there's just a massive amount of upkeep that's required. There's
Yeah.
intervention with chemicals and practices to try to keep this space clean. And the biggest part of it is this aerosol, right? Uh, so there's a study linked on the second page in one of the words.
Hmm.
You don't have to go to it now, but there's a couple of these studies. They've been around forever. I mean, all the dental handpiece companies know about this problem, and it's this aerosol generation. And
Hmm.
you need sprays to cool teeth. So handpieces generate spray by combining compressed air and water. And again, if you look at it from an engineering standpoint, it's like if you were to create the perfect habitable environment for bacteria and virus spray. I mean, you couldn't design a better system. So,
Right.
and that's no problem. It's not a problem. I mean, it's not been a problem for the last 20 years. I mean, as soon as they started saying, okay, we're going to start sterilizing handpieces between each patient,
Yeah.
there wasn't really any issues. There a couple things popped up every now and then. There was a famous case in Orange, California, at a children's health clinic. There was like 12 kids. You can Google this and look it up, but there was like 12 kids that uh, got a flesh-eating bacteria because the delivery units weren't being cleaned correctly. And we're just talking about disinfecting tabs and that type of stuff, purging the lines.
Okay.
So, but now that there's this coronavirus, it's people are really focusing on the situation, and I broke it down on that. You can see the first page you had up previously.
This
It's,
one. Hmm.
yeah, I've broken it down to the three areas where immediately right now, we can do something about. We don't
Okay.
need to go back to the engineering drawing board
We
and
don't need to
start from
change
scratch.
anything
Yeah,
in, well, if you have these certain products that we're talking
yeah,
about. I should just also say right now too that like I'm not getting paid for this. There's no money exchange. This is just a company that I use and I wanted to know, and so I wanted to pass on some of this knowledge. So there's no money, no sponsorship or anything like that happening for this live.
yeah. Actually, you bought all the B&R products that you use, so
I did, yeah.
thank you for that. Yeah. Yeah, so there, first of all, the first bullet point there, cross-contamination. Okay, so if you go to the next slide,
Hmm.
we're talking about anti-retraction valves, and it's just a shuttle valve, right? It's a one-way valve. It opens up when there's water flowing through it, and it seals. It closes when there's no water flowing through it.
Okay.
Pretty simple concept, right? Something that you would think is ubiquitous and standard, but it's not, right? So close to 50% of the US practicing dentists do not have an anti-retraction valve in their handpiece. And I know that because the most common and highest selling handpieces like Midwest Tradition and Star 430 SWL, these are the handpieces that were in all the dental schools for the last 50 years. Um, you know, large there's a very large population of US dentists that are practicing now without anti-retraction valves. And once you start implementing I cannot hear you now. Hear me out. This is what I was expecting. I was surprised that it went this smoothly. All right.
Sorry, I
Sorry, guys. For some reason, I couldn't hear Daniel, and I don't think he could hear me, so let's get him back on here. Here he is. Can you hear me now? Okay.
Gotcha.
All right, good. Sorry, I don't know. This happened yesterday during my live too.
I was saying I was surprised that it didn't that it went off as smoothly as it did initially. So I was expecting
Okay,
some.
so we were talking about the anti-retraction valve, and this is a valve that cuts off water so it can't go back into the lines. Is that correct?
Exactly.
Okay.
And then, so now you have handpieces with anti-retraction valves in two locations.
Okay.
Anti-retraction valve is a small mechanical metal piece. And if it's got to be sterilized between every patient, it's much more expensive and difficult to engineer something like that. The grade of materials
Sure.
must be higher quality. So a lot of dental handpieces that have anti-retraction valves are actually in the coupler. And if you think
Okay,
through
so
that,
well, hold on real quick because I coming from my stupidity too, I want to make sure we're very particular about this. The coupler is the part that the handpiece screws into, right?
yep,
The part
thank
that is
you. Yep,
connected to the line. Okay.
yep.
You can
So
kind of see it under my image. Sorry, I have to pick one or the other, but
yeah,
yeah.
so couplers are devices that were created in post 1996, right? Most everything used to just be a screw connection, like a fixed back end, and you'd screw the dental tubing onto the handpieces. When you had
Yeah.
to begin sterilizing the handpieces, can you imagine between every patient screwing and unscrewing? So they
Yeah.
made a quick disconnect coupler.
Yeah.
That's what a coupler is. So most handpieces that use a coupler, the anti-retraction valve is in the coupler. And so when you go to sterilize the handpiece between patients, you disconnect the handpiece from the coupler. The coupler stays on the tubing and does not get sterilized. You go and sterilize your handpiece. You bring the new sterile handpiece on and connect it right back. So
So you have a portion in your coupler that didn't get sterilized and that potentially has bacteria or virus or whatever that's gone back into the coupler. And then you
exactly.
put on a sterile handpiece, and now you've just contaminated that sterile handpiece.
Yeah, and I would argue that sort of undermines the point of an anti-retraction valve, right?
Right.
So that's an example of uh, adding a feature to satisfy the letter of the law, but not being in tune with the spirit of it, right?
Right. So
Um,
so other companies may say like, "Oh, we have an anti-retraction valve." So
exactly.
check box, right? But
Yes.
does it actually keep the patient safe, let's say? And most of the
Yeah.
time that would be no, right?
Yeah. I mean, that's not for me to say. I'm not a scientist or
Yeah.
an
Are
FDA
there
advisor, but
studies on that? Do you know?
there are studies on anti-retraction valves. There's a link to it on your slide.
Uh-huh.
In blue right there, there's a
Oh.
hyperlink. I don't think you should
Mm-hmm.
go to it because it'll be too small to read. But
Yeah.
you guys can Google it. If you just Google COVID-19 in dental practices, this is the study that's coming up.
Okay.
This group of people they produce a study very quickly about the risk of COVID-19 spreading, and it's all about anti-retraction valve and aerosols. It's all in there.
Yeah.
It doesn't really go into the location of the anti-retraction valve,
Okay.
but it's just an example. I mean, it's not technically, obviously, an anti-retraction valve is not a requirement, right? It's
Yeah.
not even in dentistry a requirement. It's just become the standard of care, and so studies like this that say anti-retraction valve, well, the marketplace can produce a product that provides that feature to an user, but the user, unless they're sort of explained how this works, they can't logically come to the conclusion that, oh, it'd be much better to have it in the handpiece, right?
Right.
Um, and it's sort of,
So is this a requirement by the CDC to have an anti-retraction valve, or no, it's just a recommendation?
no, it's not. It's not. Yeah, it's
Just a
not even a
recommendation.
recommendation by them. No,
Okay.
it's now in this new study. So in the the dental journals and, you know, in the academia side of it, it's very, very well known, like that anti-retraction valves are recommended.
Yeah.
But, you know, legally speaking, they're not recommended. That's why still half of the US practicing dentists don't have one. But it's not a requirement.
Okay. Okay. Let's, I don't know if you're going to go into, yeah, I guess you're going to go into like electric handpieces versus air-driven handpieces, right?
Yeah.
Okay. Should I
And
go to
that'll be
one
the
of these
next
other
slide.
slides?
Yeah. So that's
Okay.
aerosol. Okay.
Okay.
All right. So, BNR is in 42 dental schools in the US. USC, right?
Yep. The one that I teach at. Yeah.
Yeah.
Okay. Or I guess used to teach at. It's been a year now.
Right.
Too busy now.
Yeah, right. So one thing I learned or I thought was interesting when I started going through the academia side in the dental business for handpieces is, you know, most of the treatments, most of the materials that you use, most of the courses that you teach, especially on your implant surgery side, it's all data driven, right?
Yeah.
100% of it.
Right.
It's like,
As
yeah,
much as
so
possible. Yeah.
much as possible, right? However, there's sort of this glaring anomaly in the dental business, which is the dental handpiece. Okay, so the story of BNR actually is our founder had his friend was a dentist, and back then in 1959, they were using the rubber band belt-driven handpieces,
Oh
and
yeah,
it only
yeah.
went,
Uh-huh.
yeah. So technically an electric handpiece because it was ran by a big electric motor on the ground. It's just that at the time they couldn't miniaturize electric motors.
Yeah.
So, but it only ran 4,000 RPM. And the reason why my company exists is because the owner of my company or the founder is he was a watch mechanic, and his dentist friend said, you know, I think I can reduce faster if I got a higher speed. So he made a ball bearing handpiece, right? Now, ball bearing handpieces are so small that they require such a high speed to produce torque, and torque and speed is related.
Okay.
So you're sort of what was intriguing to me is that in this you know in this data driven clinical environment where all the materials and all the techniques and all the procedures are sort of, you know, built up in this structure of like you know, trial and error and the scientific process, basically a dental handpiece bearing confines you to what speed you're going to practice at, right? So
Okay.
so you know, air-driven handpieces, they spin at 420,000 RPM. The reason why is not because a panel of dentists you know, did a study and said this is what we feel the best speed to reduce enamel is. It's because when something's that small, a rotary device is that small, it has to have that speed in order to have any torque to cut enamel.
Yeah.
So now going into electric handpieces, right? Speed and torque are mutually exclusive.
Okay.
You can have full torque at any speed.
Yeah. This is
So,
something that Pascal sold me on early.
right.
Yeah.
And you feel that, right? I mean, I'm talking about your technique, the way you cut the tooth. It's like you sort of, I know very closely seen you practice. And you know, you understand that if you just leave the handpiece there and let the burr start to cut, it will start to cut. But
Yeah.
in air driven, they're constantly swiping it like this because they don't want it to slow down.
Right. And I've had that
Okay.
before too, working with air-driven handpieces when I was working in other people's offices, is I could actually get it to stop, you know,
Right,
and it would actually stop.
right.
Yeah.
So going from, you know, the air driven handpiece needing that high speed, and you add the fact that if you use an aggressive burr, it will bite like you described and slow down
Yeah.
fast.
Mm-hmm.
So then you're using sort of a finer diamond, and the engineering term for what you're doing to the enamel is called grinding. It's not cutting.
Okay.
So the reduction is a result of this grinding. So then what you had is the problem in dentistry where you needed to cool the tooth.
Yeah.
So dental handpieces started
Because
to
you're not
produce, you know,
cutting, you're grinding, right?
exactly. So the
Yeah.
problem is, right, if you're generating heat, if the burr is spinning and contacting the tooth surface, and that heat is allowed to be absorbed or retained by the enamel, that's when you can kill the pulp. That's when you can
Yeah.
kill the tooth. If
Yeah.
you cut that enamel off and excavate it fast enough, and this is an engineering principle that's known, like this is the problem with machining titanium, it's that it retains so much heat. So you have to be able to cut it so fast and get rid of it
Right.
so that it doesn't overheat. So,
Yeah.
you know, we're sort of, I'm describing this situation with air-driven handpieces where you're confined at that speed because you need to have it to produce torque. And then because of that speed, you're generating heat because you're grinding.
I
So
see.
then you come in and try to make a spray, right? And
To
now
make sure it doesn't
some of the
overheat.
things, so now you've got to manage the heat. So now you produce aerosol.
Yeah.
And now we're adding a third or fourth layer on that, which I've seen is now that there are some people that are going to buy a vacuum, and
Mm-hmm.
you know, it's a big standing vacuum, and they put the funnel over
Yeah.
the patient's mouth. And the
Mm-hmm.
hope is, and I don't know if you've ever seen like a video illustration of aerosol, like
Yeah,
there's,
I have where it's red and yeah.
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 So can you imagine like a little, I mean, it's very wishful thinking that this little vacuum is gonna, you know,
Yeah.
evacuate all of this aerosol that's produced. So
Yeah.
you
We
know,
need
in
some studies
dentistry,
on it.
yeah. And there's some, you know, like they're doing the video generations of people wearing masks to illustrate like when
Oh,
you cough, it goes everywhere. I mean, it's
yeah.
just to try to stick a vacuum hose in your face when you cough. I mean, it's a little bit hopeful, you know. So
So then,
what
so then why do you think, I know, I don't know what the percentage is in the US, maybe you know this, but I know it's low, the percentage of people in the US that use electric handpieces. Do you know what that percentage is?
from my experience, it's around 20% that use
20%.
electric
So very
handpieces.
low. I think it's much higher in Europe.
Yeah, so not, and this is something that's uh, people always they never believe me when I say this, but you know, BNR, we manufacture the most electric motors for dental and surgical applications in the world. We produce 60,000 motors a year.
Okay.
And the reason is because in the rest of the world and in the USA, we're actually an OEM business. We sell to
Hmm.
chair manufacturers. So we have a pretty good idea, you know, the land